Good day friends. First I want to say welcome to the new year, to 2023. In this video, the first for this year, I'm going to talk about singly linked lists. Singly linked lists are a type of linked list data structures in Python. In this video, I'll tell you what a linked list is, the disadvantages and advantages of linked lists, when you can use a linked list, and also I'll tell you the characteristic of a singly linked list, how you can create a singly linked list, and how to add nodes to a singly linked list. In the coming video, which will come shortly after this, I'll show you how to delete nodes from a singly linked list, how to search for a node, how to sort a singly linked list, and also how to return the end node from the end of a singly linked list. So let's get started. First, what is a linked list? You can imagine a linked list to be like a chain. A chain has items and it has a connector for each of the items. That is how a linked list is. In a linked list, each of the items or elements is called a node, and each node has a value or data and also a pointer to the node after it's called next. You can see it in this graphic here. You can see we have a linked list with 4 nodes: A with data A, data B, data C, and data D. The start of the linked list has a head node, and the end of the linked list points to a null. You can see that the pointer for each node is called next. The characteristics of single linked lists and double linked lists is that single linked lists have nodes which have only one pointer, pointing to the next node, while double linked lists has 2 pointers, the next node and the previous nodes. So like a chain, a linked list have connections between nodes that we call pointers. Now, what are the advantages of linked lists? One advantage of linked lists is that you can add and remove nodes in constant time, unlike in an array where you have to shift the elements because they are in contiguous locations in memory. You have to shift them to shrink or to grow it. But in a node, you can shrink or grow in constant time. No problem at all. And also, linked lists do not have fixed sizes, or they do not require an initial size. They can grow and shrink at will. But linked lists also have disadvantages. One disadvantage is the space problem. They take up more memory space compared to array data structures. Why is it like that? Because the node of a linked list has a pointer. For example, you have a linked list that has 1000 nodes. That means it will have 1000 pointers. Imagine the memory space these pointers will take up. Also, search operations in linked lists are slower than in arrays. Why is this so? Because in search operation, you have to traverse the nodes. You have to go through the nodes one after the other, which takes up linear time. But in arrays, because you have the index and you can search for the index, it takes up a constant time due to the indexing. So when can you use linked lists? You can use linked lists when the number of items or nodes is unknown at the start, or when you don't need random access to elements like in arrays, or when you want the ability to grow or shrink the linked list at any point, or if you need fast insertion or deletion of nodes or items from the list, you need the linked list. And you can see that linked lists have wide applications. You can use them in stacks. We'll discuss about that later. You can use them in queues, graphs, and in dynamic memory allocation. We'll discuss all about this in subsequent videos. One example of a linked list in action is in your web browser. You see the forward and backward buttons on your web browser. They are using a linked list because the browser can know what comes next, the pages that come next, and the pages that comes previously. That's a doubly linked list, if I might tell you. So you know an example of a linked list in action. Now, let me show you how to create and use a single linked list. But by now you must have known the characteristics or difference between a single linked list and a double linked list. In a single linked list, the nodes have only one pointer that points to the node after it. But in a double linked list, the nodes have 2 pointers. The forward pointer that points to the node after it, and the backward pointer that points to the previous node. So that's just the only way you distinguish a single linked list from a double linked list. Now let's go to the coding proper. Let me show you how you can code a single linked list. Creating a single linked list. To create a single linked list, you need to have 2 classes. Let me show you why. You can see in this diagram of a linked list, you can see that one, we have nodes connected by the next pointer. Then all these nodes are aggregated into a linked list. So we need 2 objects. We need the node object and the linked list object. So you can see that the node object has the data, path attribute, and the next attribute. So let's first create the node class. We'll initialize it with the init, and when we initialize it, we'll pass in the data. Then we'll create the attribute self.data, which pass in the data, and then self.next. Initially, when you first create a node, it points to none. The next is none. We'll see that inside the linked list manages this and makes this point to something. Then we'll create the linked list class or object. We initialize it first, and we'll just give it self.head pointing to none. When you create an empty linked list object, you just have a head, which is this. You just have a head, which is this. The head pointer that doesn't have any nodes yet. That's why self.head is none. As we go on, we'll populate it. Now we need the ability to print the content of a linked list. We need the ability to print the content of a linked list. I'll create the method now for it. We'll print it as a string. So I'll create this string object. Then we need the ability to traverse the linked list. So I'll create a temp variable that will go through each of the nodes in a loop. It's saying there's an error here. Okay. Okay, return. I wanted to write results. I was wondering what the error was. Say result is, so it goes through the loop, and in the loop, when it goes to a node, it says give me the data for that node. Then in the string, we'll add this marker that shows you what comes next. Then when you get the data, you go on to the next node. That's all. We have traversed it. Now you see this marker at the end. We want to remove it from the last data, from the last node or string. Remove a marker from the end. How we do it is I will just strip it out. We'll just strip it out. Result of strip. Just strip it out. Then we'll check if result is empty or not. So say if result has something in it, just print out the string. But if it's empty, or else is empty linked list, else is empty, just print linked list is empty. Print an empty container. That's it. So I'll give you code for constructing a basic linked list. So let's implement this. I'll manually create the nodes here, but after this I'll create a function where we'll just pass in the data and the linked list will create the nodes automatically. I'll manually create the nodes here. I want to create a linked list like this. A linked list that has 1 as the data for the first node, 2 as data for the second node, and 3 as the data for the last node. So we'll use this as guide. So say first, we'll create the nodes manually, then second, third. When you create a node, you pass in the data. Then I'll now create the link. Don't know why this keyboard is misbehaving. I'll now create the link list, this object. So I'll say link list, initialize it. Now we add the head node. You should just say link list dot head becomes the first. Get it? Then first dot next points to the second. Second dot next points to the third. That's all you need. Then we'll now print. I'll now print it. Let's print it and see. You can see we've successfully created the. See what we did here. First, I created the three nodes, this, and this. Created the linked list object. Then the head becomes the points to the first. Then the next for the first points to the second. The next for the second points to the third, and we have the next for the first points to the second. Next for the second points to the third. Then we have our linked list. Now, this is the manual way to add nodes and create nodes. I will give you a function. I will now give you a functional way of doing this using a method in the linked list. I'll give you a better way to do this. I'll create a method that will add nodes at a position. What it does is that it takes the data and takes the position. Now, to add that position, we need to first create the node. So all we need to do is I will say new node, also node, new data. Is that date arrow there? Okay, it's date. New data. Good. Now, this is what we need to do next. We need to note that a position has constraints. A position cannot be below 1. Below 1. So we need to check for that. If position is less than 1, position is less than 1, we return. We can't go further than that. If position is less than 1, we return. We just print start from position 1 and we return. Can't go further than that. But else, if position is 1, if it's an empty linked list, you know position, you start from 1 because you must have something. If an empty linked list, you know you have to start position from 1. So how do you do it if you get an empty linked list? Let me show you through the diagram. You see, an empty linked list doesn't have nodes. It just has the head pointer pointing to none. So what you just do is that you just point the head pointer to the node. But if it already has nodes, and for example A is the head, what you do is that the new node that you want to be the head will point to this A, and the head pointer will point to the new node. So that's what we are going to do right here. So let new node point to the previous head. Let the new node point to the previous head. So we'll say new node.next will be self.head. Now the head pointer will now point to the new node. Self.head will now point to the new node, and that's all you need to do to put your node at position 1. Now if you are not putting it at position 1 from 2 upwards, that was our else here. Position from 2 and above. So what you need to do now, you need to check if you have a previous position. So we start by creating the temp variable. So we say we are going to traverse the node from, we'll traverse the linked list, traverse the nodes from the head until we get to the previous position. You know, if you are going to put it at position 3, the previous position is 2. So traverse the node from 1 to 2. If you are going to put it at position 6, the previous position is 5. So traverse the nodes from 1 to 5. So that's what we are going to do for I in range 1 to position -1. So when we get to each node, we check if it's the last node. If temp is not none. If it's not the last node, we'll move. If it's not the previous node or the last node, we'll move to the next. So we keep on traversing until we get to our previous position. So when we have ended the traversal and we are at our previous position, now we check if previous node, check if previous position or node points to or node doesn't exist. So we want to check if previous node doesn't. So we'll say if temp is not none. You know that if temp is none, that means the previous node doesn't exist. But if temp is just none, that means the previous node exists. So what we do is that we ask ourselves, what is the previous node pointing to? Now let the new node point to what the previous node is pointing to, and the previous node will now point to the new node. Remember, temp is our previous node when we go through the traversal. So we say let the new node point to the node the previous node is pointing to, or the next node. Then let the previous node point to the new node. Let the previous node point to the new node. But if the previous node doesn't exist, we just print out and tell you that the previous node is null. So that's all for creating a method that inserts at a given position, maybe 1 or something after 1. Now let's put this into action. First, I'll create the linked list of now I don't create the nodes manually, I create the linked list object, and when we are inserting, we'll just give it the data and it will automatically create the node and put it at the position. So I want to do something like this. I want to say 1 is the first node, 7 is the second node, 9 is the fourth node. Then I'll show you that this can shrink and grow at will. Now, so I've created the linked list object. So you cannot start without the head node. So we'll say let's create the head node dot insert at position, give it the data data is 1, the position is 1. Now let's see what we created to print content. So you see that to print only 1 to show you that this is the head node. See, it printed only 1 to show that this is the head node. Now let's insert 6, which is the second. Insert at position, data is 6, position is 2. This dot print contents. See, 1 6. Now what if I insert 10? 10 is supposed to be 1 2 3 4 5. 10 is supposed to be at position 5, but I say let me put 10 at position 3 just to show you how you can shrink and grow at will in constant time. Data is 10 3. I'm giving it 3 because you need a previous node. So you see 1 6 10. Now let's insert 7. 7 is at position 3. So if I say insert at position 7 3, you see we have 3, you have 3. What will happen is that since this 3 will come between 6 and 10, it will move, it will just change the chain instantly, and 10 will become node 4. You can see it now. You see how you can shrink and grow at will. Now 1 2 3 4. If we want to insert 9, 9 will be at position 4. This dot insert at position 9, position 4. So we have what we sought out to create. So now I believe that you understand how to create single linked lists and how to insert nodes at a given position. In my next video, which I'll post this week, I'll show you how you can delete nodes, search for a node, sort a single linked list, and also return the end node from the end of a single linked list. So that's all for today. I encourage you to subscribe to this channel and to like this video. It encourages me to produce more interesting videos like this that takes you from being a Python novice to a Python pro. Thank you very much. Have a nice day. I'll see you some other time.